Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to the lecturers and my fellow friends. My name is Mohamad Zhuhair bin Mohamad Shofi, and I will be presenting my final year project, which is behavior of iron ore tire sinter. As for the background of this project, even though in this modern era, steel is considered as essential and very important factor for the economic growth of a country, especially in the construction and automobile industry. However, steelmaking industry is considered as one of the largest energy consuming sector. So the problem with steel production is that it has a short of raw material supplies, which is high-grade iron ore and metallurgical coke, and also the emission of CO2 in enormous quantities. As for the problem statement for this project, it can be divided into four, which is first, the production of coke require high energy and cost, which the coal need to be heated up to around 1000 degrees Celsius for about 22 to 24 hours. Next, the production of coke also resulted to byproducts such as benzene, toluene, xylene, ammonium naphthalene, tar vapor, and also 290 kg of CO carbon dioxide. Next, sintering also released almost the same amount of carbon dioxide, which is around 216 kg. And finally, the management of waste tires disposal are challenging due to its poor biodegradable and carcinogenic property. So as a solution to this problem, char made from utilizing the waste tire could be a potential resource to be used as a fuel for the iron ore. However, properties, condition, and process have not been established yet. Thus, a research study regarding the utilization of the char for the sintering process, for the char tire for the sintering process should be conducted. So the proposed process for this project is that the waste tires will be collected and cut into small pieces, where it will undergo pyrolysis process to produce the char tire. Then the char will be mixed with local iron ore and also water as a binder to produce the iron sinter. For the whole methodology of this project is that the raw materials will be collected, which is iron ore and tire, and the tire will be cut into small pieces to undergo heating process at 550 degrees Celsius to produce the char tire. Then the char tire in the form of powder will be mixed with the iron ore at 6% and 8% ratio to produce the iron ore tire compound. Then the compound will undergo sintering process at 3 different temperatures, which is 1100, 1200, and 1250 degrees Celsius to produce the sinter product. As for the characterization involved in this project is that XRF and TGA to identify the elemental composition and also the weight loss percent involved in this reduction reaction. Next, carbon analyzer, which is to identify the carbon content of the char tire produced. Next, reduction degree analysis, which is to see how much of the iron has been reduced. Next, volume shrinkage and density analysis, which is to study the effect of different composition and temperature on the sintered product, and also XRD to identify any phase changes in the iron sinter. So the objectives of this project is that to study the effect of different temperature and char tire composition on the characteristics of the sintered product, and also second is to study the phase change of a sintered product. For the results of the experiment, please take note that at the result section for the elaboration, there are some terms used for the iron phases, where the reduction reaction involved at the first reduction reaction is from hematite to magnetite, the second reduction reaction from magnetite to wustite, and the third reduction reaction from wustite to metallic iron phase. This is the elemental composition of iron ore, which is the characterization results obtained from using the SRF. As you can see from the table above, this is the unnormalized composition in weight percentage, where SRF cannot detect all of the elemental composition, especially light materials. However, heavy metal element are highly reliable. So as you can see from the table, the iron content is 55.60%. Thus proves the material used for this project is a low grade iron ore, following the second highest composition, which is the oxygen at 27.71%, and also aluminium, silicon, titanium, cobalt, manganese, which is considered as impurities according to a literature review or a previous research. Next, this is the thermal degradation of the iron ore. As you can see, based on the graph, the Tg% or the weight loss in percent of iron ore throughout the experiment temperature is 13.58%. And this is the thermal degradation of Zhuhair, as you can see from the graph. From the Tg% graph, the total weight loss of the Zhuhair throughout the reduction process will be 5.078%. The both value of the total weight loss are crucial because it will be used in the calculation of the reduction degree. This is the graph showing the effect of different temperature and Zhuhair addition on the average weight loss. As you can see from the graph, the two graphs show the same trend, which is increasing as the temperature increase. However, at 6% composition, the weight loss are slightly lower compared to 8% composition. Thus, a higher temperature resulted in more weight loss due to the reduction reaction, which involves the oxygen removal and other impurities. Likewise, with respect to the composition, the average weight loss percentage increase for Sinter with higher composition compared to lower composition, which showed as to how much the composition managed to reduce the oxygen or the weight of the Sinter. This is the effect of different temperature and Zhuhair addition on the reduction degree. And as you can see from the graph, at 6% Zhuhair addition, the reduction degree at 1100 degrees Celsius is 1.452, and for the second reduction reaction it reached to 3.409, and lastly at 1250 degrees Celsius it reached to 4.499. Thus, when compared to the theoretical level or the green line, this shows that the hematite has been partially reduced to magnetite since it did not reach the supposed theoretical level. It has been partially reduced to magnetite. Then the second reduction reaction, the magnetite has been partially reduced to woolstite, and at 1250 degrees Celsius, the woolstite has been slightly reduced to iron, while having most of the iron phase in woolstite and magnetite. However, at 8% ratio, the 1100 degrees Celsius, the reduction degree is 3.691, which exceed the theoretical value, which is 3.33. Next, at 1200, at 5.523%. Next, at 1250 degrees Celsius, it reached 6.263%. Thus, can be concluded that the hematite has been completely reduced to magnetite at the first reduction reaction. Next, the magnetite has been partially reduced to woolstite, and lastly, at 1250 degrees Celsius, the woolstite has been slightly reduced to iron, with the majority of the iron phase consists of magnetite and woolstite. Even though at both composition, the third reduction degree did not reach the supposed theoretical level. However, there are existing woolstite phase that has been reduced to iron, which can be seen at the phase changes later. This is the effect of temperature and Zhuhair addition on the volume of the sinter. As you can see, the volume shrinkage for the 6%, 53% at 1100 degree, and slightly increased to 55.30%, and lastly at 57.30%. However, at 8% composition, at 1100 degrees Celsius, the volume shrinkage is that 50.63%, followed by slightly increment to 56.93%, and a significant increase to 68.93%. This shows that higher firing temperature or higher sintering temperature and Zhuhair composition reduce the volume of the sinter product due to the densification of the sinter. This is the effect of temperature and Zhuhair addition on the density, and as you can see from the graph, at 6% ratio, the density of the product at 1100 degrees Celsius reached to 9.84 gram per centimeter cube, followed by 11.73 and 13.09 gram per centimeter cube. However, at 8% ratio, the density comes out higher compared to 6%, which is at 10.70 gram per centimeter cube, followed by a slight increment to 13.62 and a significant increase at 19.63 gram per centimeter cube. Thus, this showed that the higher sintering temperature will result in higher average apparent density with respect to the increased Zhuhair. This is the chemical compound composition of the original iron ore. From the XRD peak, it can be seen that the major iron compound, major phase of the iron consists of goethite, which is common in local iron ore due to its high water composition, followed by the second highest measuring peak consists of hematite and also firelite and woolstite. This is the phase change of sinter product at different temperature for 6% comparing to the original composition just now. At 1100 degrees Celsius firing temperature, there are still some goethite exists that has not been reduced to hematite, followed by slight magnetite phase, woolstite, quartz, and also firelite, which is resulted from the bonding of iron and silica. Next, at 1200 degrees Celsius, most of the hematite have been reduced to magnetite phase, and also woolstite, followed by slight iron and also the existing quartz. Next, at 1250 degrees Celsius, most of the magnetite remains, and some also converted to woolstite, and also there are slight metallic iron phase exists, and also quartz remain. And also this is the phase change of sinter product at different temperature. for the 8% ratio. As you can see from the peak different from the 6% composition, most of the geotite have been reduced to hematite, which makes the major existing phase in the sample at 1100 degrees Celsius consists of hematite, while some of it also reduced to magnetite, and a slight quartz can also be found. Next, at 1200 degrees Celsius, the hematite have been reduced to magnetite, and some magnetite have started to reduce to wustite with slight metallic iron phase can be observed, and existing quartz from the original sample. Next, at 1250 degrees Celsius, most of the magnetite reduced to wustite, while some of it remains, and also some of the wustite have been slightly or partially reduced to metallic iron phase, and also the quartz remain. As for the conclusion of this project, the characterization of the tire-derived char actually showed high possibility of the char tire as a replacement of coke due to its high amount of carbon content, ranging from 65% to 86% of carbon content from the carbon analyzer test. Second, this experiment actually proved that the higher the char content will result in higher weight loss, which contribute to higher reduction degree with respect to increasing temperature. Third, based on the results, the highest volumetric shrinkage, density and reduction degree achieved for the iron sinter was the sinter with 8% composition of char tire content, which are 68.93% of shrinkage, 19.63% for the density, and 6.263% of reduction degree respectively at 1250 degrees Celsius, followed by the phase change from hematite to majority of wustite and metallic iron. This actually indicates the higher amount of char was required to achieve higher reduction degree. That's basically all of it. Thanks for lending me your ears. Thank you.